Hello everyone, my name is Xubo Liu from the University of Surrey. Today I will present my CVPR paper, Sims VSR, Scaling Up Visual Speech Recognition with Synthetic Supervision, which is done during my internship at Meta. Visual speech recognition is the task of recognizing speech content based on visual lip movements. The key challenge of VSR is the lack of the large-scale labeled video data, which potentially results in poor performance. In this work, we propose Sims VSR, a semi-supervised framework for VSR. Sims VSR generates synthetic lip movement videos from the labeled speech datasets and the face dataset. Such synthetic visual data paired with the speech transcriptions could significantly improve the performance of VSR systems via semi-supervised training. Sims VSR has achieved the state-of-the-art word area 16.9% on ARS3 benchmark and outperforms the previously measured using 29 times more data. The recently reported state-of-the-art results in VSR often relied on the increasing large amounts of video data. These methods can be generally divided into three categories. The first one is to collect large-scale non-public transcribed audiovisual datasets, such as Google's 90,000 hours of data from YouTube. The second one is to use the off-the-shelf ASR models to generate the pseudo-transcriptions for the unlabeled audiovisual data. And then we can use the pseudo-labeled data for the semi-supervised learning. The third one is to explore the self-supervised learning on the unlabeled audiovisual data, such as the A.V. Hubbard method. However, publicly available audiovisual datasets are limited in size. Such video data, including speakers' frontal face, is not easy to collect, and annotating video data is resource-intensive. Also, it's not easy to scale up. In addition, the usage of publicly available datasets may raise privacy, bias, or licensing-related concerns, such as the LW and LS2 datasets are only available for academic research purposes, which barring the development of VSR in real-world scenarios. In this work, we present Sims VSR, a novel semi-supervised framework for VSR. We first propose a speech-driven lip animation model that can generate synthetic lip movement video conditioned on the speech content. Next, the proposed lip animation model is used to generate synthetic video clips from the transcribed speech datasets such as Libre speech and human face datasets such as CLAB-A. Then, the synthetic videos together with the corresponding transcriptions are used in combination with the real video text pairs, such as the LS3 dataset, for the large-scale semi-supervised learning. Unlike existing studies in exploiting the unlabeled video data for VSR using methods such as the pseudo-labeling and the self-supervised learning, we use the unlabeled audiovisual data to train a cross-model generative model in order to bridge the ASR and face data with the VSR. Our proposed Sims VSR offers a practically infinite data diversity such as the identities and text labels for scaling up VSR. Our proposed speech-driven lip animation model is based on a temporal GAN with two discriminators. The frame discriminator is used to enforce the visual consistency, and the sequence discriminator is used to ensure the temporal consistency. We further propose a VSR perceptual loss when labeled video data is available. Specifically, we first train a VSR model, and the proposed VSR perceptual loss corresponds to a weighted sum of the distance computed from the visual features and the predict losses of the pre-trained VSR model for real and generated video samples. The total training loss of the speech-driven lip animation model is a combination of the frame discriminator loss, the sequence discriminator loss, our proposed VSR perceptual loss, and a pixel-level reconstruction loss. The output space of the speech-driven lip animation model is the same as the VSR input space. To generate the large-scale synthetic data for semi-supervised VSR training, we use a speech corpora of the 3,652 hours of data consisting of Libre speech, Telio, and Common Voice, and then we use CLAB-A as a face source. We generated one synthetic video per speech clip with one random select lip image. Our method is easy to scale up and results in an unlimited data generation pipeline. Then let's see some examples of the synthetic lip movement videos generated from Libre speech and CLAB-A.
Because a correspondence is one of the forbidden things. He says he entered into no contract not to write, and keeps slipping little notes into my hand.
Lady Georgina inquired, growing affable. He twirled his grey moustache, a waxed moustache of great distinction.
And he cried himself to sleep the first night, and he cried all the next day, when sent around with meat on his shoulder.
In short, to our former life. These last words fell on Mousqueton like a thunderbolt.
He was informed at the White House that General Beauregard was there, and sending in his card, he was admitted promptly.
We train our speech-driven limb animation model on LR3 with AV speech datasets. For the VSR model, we use a conformer transformer encoder decoder architecture, which has achieved the state-of-the-art results on LR3 benchmark. We experiment with the base model and the large model. The training and evaluation configuration is consistent with the previous work for the fair comparison. We evaluate the performance of Sims VSR on the largest public VSR benchmark LR3 with multiple label data setup. The first one is a low-resource setup, which only uses 30 hours of the label data from LR3. The second one is a benchmark setup, which uses 438 hours of label data from LR3. The third one is a high-resource setup. We use additional 2,630 hours of ASR pseudo-labeled public audiovisual data. In the low-resource setup, our method achieves a VSR warning rate of 43.3%, substantially outperforming the former method using hundreds or thousands of hours of video data for supervised training or self-supervised learning. Notably, we show the first successful attempt that trains a VSR model with acceptable warning rate performance using only 30 hours of real video data. Using the complete 438 hours label data from LR3 further improves the warning rate to 27.9%, which is on par with the state-of-the-art self-supervised method AV Hooper Large that use external 1,759 hours of unlabeled audiovisual data for self-supervised training, but our method with fewer model parameters. Using additional 2,630 hours of ASR pseudo-labeled public audiovisual data, Sims VSR achieves the state-of-the-art warning rate 16.9% on LR3 with publicly available data only, slightly surpassing the former SOTA method using 90,000 hours of non-public machine transcribed data. Our method reduces the need for large-scale annotated visual data for VSR and is potentially useful in low-resource language or new VSR applications, where label data is limited. Furthermore, we are the first benchmark with publicly available synthetic data, and we hope our work fosters future work in this field. How to better generate and leverage synthetic visual data could be an interesting future direction.